Who would have imagined that the first indications of life would be discovered on a planet just 120 light-years away from us? Once again, we are dealing with a true masterpiece of the James Webb Space Telescope. Just over 120 light-years from the Earth, the exoplanet K2-18B has already cemented its place in astronomy's history books. It orbits a red dwarf star and exhibits some significant signs of biological processes, making it one of the most sought-after objects of study today. James Webb was able to find 4 signatures of life forms in the planet's environment, which is currently considered an absolute exception. This marvel of technology used its keen eyes to look at a distant world and discovered the first signs of extraterrestrial life there. Thanks to James Webb's perfect spectrometer analyses, the sensational report has stoked many hopes of finally discovering real life in the universe. Scientists were able to quickly determine that this world plays a special role among exoplanets, when the analyses revealed evidence of large amounts of water at the beginning of the study. What followed could forever alter our science because, for the first time, we are looking at a planet that can answer the questions of what life actually is and how it arises. Additionally, this world could demonstrate to us that the diversity of life in the universe is greater than we may have predicted, that the study of K2-18B may be the first step in providing answers to the issues of how many life forms exist in the cosmos and what they look like. These topics are of interest to both scientists and many laypeople. 4 biomarkers were discovered for the first time, and they not only show that the planet is water-rich, but also that there is evidence of alien life in the K2-18B environment. Among other things, methane and carbon dioxide were detected. Both gases are unmistakable signs of organic IC processes and life-dimethyl sulfide, particularly when they coexist. K2-18B proof of dimethyl sulfide, or DMS for short, is a gas that is almost unquestionably considered proof of love life. On Earth, it isn't particularly spectacular, but in the universe, it is produced during the metabolism of algae and occurs in large quantities near seas, oceans, and large wetlands. Life methane, carbon dioxide, and water might already be considered a jackpot in the search for life in the universe. But now we have the first spectrometer analysis of a planet that exhibits such obvious signs of life that the find is considered a scientific sensation. You can already imagine that the discovery of DMS near a planet means that there must be life in the oceans of this exoplanet. Algae are the simplest life forms on our planet, and most likely inhabited the oceans of the primordial Earth long before the first simple fish, snails, and mollusks appeared. However, algae were most likely the precursor to this life, and these plants may be one of the keys we need to understand the evolution of life. Despite its sensational nature, the discovery of DMS on K2-18B is still being handled carefully. Respectable. Scientists do not want to discuss finding the first aliens just yet, even though everything suggests it. DMS, methane, carbon dioxide, and a lot of water are all strong signs of the first habitable planet we have discovered in the universe. Let's examine methane in more detail. Given how closely methane is linked to life, the likelihood of life on K2-18B increases significantly once more. By way of contrast, James Webb's accurate spectrometer studies revealed a combination of carbon dioxide and methane that testifies to a biologically active world. Titan, Saturn's moon, for instance, has high methane levels but lacks other indicators, like oxygen or water. Titan is either deserted or has just a few extremely basic methane-based microbes. One of the biggest mysteries of the evolution of life is whether warm waters with algae must eventually create higher life, and that is exactly what we want to discover. Methane is mostly produced by microorganisms, but it can also come from ruminant gastrointestinal tracts and large rice paddies. K2-18B and the fascinating discovery of biosignatures in the planet's environment could be another significant step towards understanding how life arises in the universe and how it spreads on Earth. What does the surface of K2-18B look like? We can do a lot, but we are not yet able to look at the surface of exoplanets precisely. Methanogenic microorganisms do not live in methane, but they produce it as part of their metabolic process along with DMS. The methane deposits on K2-18B indicate at least one thing: a lot of plant life on Earth. Algae and some phytoplankton species produce large amounts of DMS, which can then be found in our planet's atmosphere. These decomposition processes in coastal ecosystems produce dimethyl sulfonio-propionate. By analyzing light that far off, planets absorb from their stars and then re-emit, the James Webb Telescope's spectrometers produce a unique pattern of light in various wavelengths. Unlike forests, mountains, or deserts, water and seas reflect light in diverse ways. In the case of K2-18B, we can use our technology to see a sort of light imprint of the planet, but we don't have an exact image of the surface. Instead, we see the ocean vapors, the metabolic products of algae or single-celled organisms, and we may be able to scan the carbon dioxide exhaled by life forms that inhabit such a world. But we can't see these life forms, so we can't tell exactly what they look like. The Webb telescope can look for gases in the planet's environment to find biomarkers like methane and DMS. K2-18B, a massive water world that is around 8.6 times the size of Earth and covered in a dense hydrogen atmosphere, is one of the so-called Hycean worlds, a class of planets that astronomers have just recently discovered in the cosmos, according to data from the James Webb Space Telescope. Since scientists had previously believed that water was very uncommon in the cosmos, the finding of the Hycean worlds was highly unexpected. It seemed as if enormous cosmic flying water droplets had just materialized before the researchers' eyes. Imagine an ocean-covered superworld with an abundance of life in its oceans. Hycean worlds are even more covered by water than our Earth and are much larger than typical rocky worlds. This makes this type of planet especially exciting because where there is so much water, the probability of life is very, very high. These planets are also frequently a little warmer than our Earth and could resemble large, warm greenhouses if they are not too hot. We also cannot rule out the idea that such a planet may create higher life forms that are confined to the water. Civilization. Water worlds could be strange hybrid animals formed of fish and intelligent life forms, similar to the most beautiful reefs in our waters. Although we will have to wait and see, scientists are currently developing new technology that will allow us to better scan biomarkers and metabolic products on distant planets in order to ascertain whether there are any additional similarities to life forms on our planet. K2-18B may be the first indication of abundant life in the universe, and we can hope that our science fiction fantasies of crazy aliens and colorful life forms will soon come true. JWST is a hot Jupiter in the constellation Pisces that orbits so close to its star that its day side is heated to an astounding 2400 degrees Celsius, hot enough to vaporize iron. Although it may not be one of the top candidates for finding life in space, this planet is continuously posing new mysteries to astronomers because of its strange glow. However, it's not just these extreme temperatures that fascinate scientists. The glory effect is a unique atmospheric light scattering on Earth that is created by misty mountains or dense cloud layers. When sunbeams strike water droplets or tiny aerosols, they create a ring-shaped glow that surrounds the shadow cast on the clouds, creating a radiant halo. In recent years, researchers have noticed an unusual phenomenon around the planet that could also help solve one of the greatest mysteries of the universe. It is unclear why this impact manifests in the surroundings of an exoplanet such as JWST. The peculiar atmosphere of this exoplanet, which is teally locked to its star and always points its day side towards the sun, while the night side is always in the dark, is probably the cause of the problem. On the hot dayite of JWST, this results in an exceptionally scorching day side and a frigid night side. Iron and other metals evaporate and disperse throughout the atmosphere. Strong winds carry the iron mist to the planet's cooler night side, where it cools and condenses once more. Iron then rains on this planet, and the perfect conditions for a glory effect are created by these metal clouds that evaporate and condense. The glow around JWST-76b is not only an interesting sight, but it also indicates exotic physical processes on and around this planet. These strange processes must cause us to question the validity of absolute physics, since we have been able to detect increasingly bizarre effects in exoplanets with the James Webb Space Telescope. Scientists believe that the ring-shaped glow around the planet is caused by the light of the nearby star being reflected and scattered by these iron clouds. The cosmos is becoming more and more like a bizarre jungle of strangeness, impossibilities, and scientific emergencies, and some scientists have questioned whether we can even begin to explain and comprehend it using our outdated physics. Get the channel's subscription today to see every new video.